Okay, welcome. Your grade A mathematics teacher, Beatrice here. Today we are going to see how we investigate skewness and kurtosis of a distribution using moments. And we are going to do that using an example. So we write this example. Like to make my space bigger. So this is the example we are going to solve. We say the marks obtained by students, the marks obtained by students in an exam were recorded as follows. So investigate the skewness and pickedness of the distribution of marks, marks. So we put down the example down here. Here are the marks, and these are the number of students who scored the marks. So we have between 0 and 20, we had 7 students. Between 20 and 40, there were 15 students. Between 40 and 60, we had 32 students. Between 60 and 80, we had 12 students. And between 80 and 100, we had 9 students. If we sum the frequencies, we are going to see that in total we had 75 students. So we want to investigate the skewness and pickedness, or the kurtosis of the distribution of marks, using moments. So we always start by getting the midpoints of the classes. 0 plus 20 is 20, dividing by 2 and get 10. 60 divided by 2 is 30. We have 50, we have 70, and we have 90. So we take, we can decide to take 50 as our assumed mean, so that we have some d there. 10 minus 50 is negative 40. We have negative 20, 0, 20, and 40. These di's are all divisible by 10, so we can have a constant 10. And when we divide each d by a constant, we get u, which will be negative 4, negative 2, 0, 2, and 4. Then we can now have fu. We have fu squared, fu cubed, and fu raised to power 4, because we are investigating both the skewness. The skewness requires up to fu cubed, but the kurtosis requires even fu raised to power 4. So f times u is negative 28, negative 30, 0, 24, 36. Fu squared is fu times u, and it gives us 112, gives us 60, 0, 48, and 144. Fu cubed is negative 448, negative 120, 0, 96, and 576. We have FU raised to power 4 as 1792. We have 240. We have 0. We have 192. And we have 3304. That is 576 times U, which is 4. So we sum the columns that require to be summed. We need to sum FU. When we sum FU, we are going to get 2. Sum FU squared, we get 364. We sum FU cubed, we get 104. We sum FU raised to power 4, we get 4528. 4528. So now, because we want to get the first 4 moments about the mean, first of all, we obtain the first 4 moments about the point 50, because our A is 50. So, first 4 moments about the point 50, about the point A is equal to 50. So we have mu1 prime is C raised to power 1 sum of FU over sum of frequencies. So this is 10 times 2 divided by 75. That gives us 0.2667. 0.2667 is the first moment about the point 50. We get mu2 prime going to be given by C squared sum of FU over sum of frequencies. C squared is 100 pi by 364, or that divided by 75. When we work out that, we should get 485.33. 485.33. We get mu3 prime, which is C raised to power 3, sum of FU, this is FU squared, sum of FU cubed over sum of F. This is going to be 1000 times 104, or this divide by 75, giving us 1366.67. 1366.67. We get mu4 prime. Mu4 prime is C raised to power 4, sum of FU raised to power 4 over sum of frequencies. This is 4528 multiplied by 10,000, or this divide by 75. When we work out that, we get 603.73 603.733 as the fourth moment about a point. So we are investigating both the pickedness and the skewness. So we will need to work out mu2, which is the second moment about the mean, and it is mu2 prime minus mu1 prime squared This is going to be 485.33 minus 0.27 approximately. All this is squared. When you work out that, we get 485.26. We can also get mu3. Mu3 is mu3 prime minus 3 mu1 prime mu2 prime plus 2 mu1 prime cubed. See what we get. We have 1386.67 minus 3 times 0.27 times 485.33, and then we are adding 2 times 0.27, and that is cubed. That is cubed. When we work out that, we get mu3 is 993.59. So that's the third moment about the mean. We can also get mu4, fourth moment about the mean. It is mu4 prime minus 4 mu1 prime mu3 prime plus 6 mu1 prime squared mu2 prime minus 3 mu1 prime, all that raised to power 4. So we substitute the values there. We have 603, 733.33, subtract 4 times 0.27 times 1366.67 plus 6 times 0.27 squared times 485.33, and we have one last term, so minus 3 times 0. We can call it 27 raised to power 4. If when you work out that, we get 602,448.0. So now we have the second moment. We know the first moment is always 0 about the mean. We have the second moment about the mean. We have the third and the fourth. We can start by investigating the pickedness or the kurtosis. So let's write kurtosis here. And we said kurtosis is given by this value, A4 is mu4 divided by mu2, all this squared. And mu4 we have just seen up here is 602,448.0. Okay, we have 602,448.0 divided by 485.26, and that is squared. That is squared. That is mu2. That is the second moment about the mean. And once we work out that, we should get 2.558. That is our coefficient of skewness of kurtosis using moments. We want to interpret it. We say that we take a 4 minus 3, and the sign tells us whether our data is highly peaked, midway peaked, or flat peaked. So this is 2.558 minus 3, and this gives us negative 0.442. And negative implies, a negative value implies platykultic. The data is flat peaked. That is good. So we move ahead now and investigate the skewness of the data. And skewness is given by this coefficient, which we call E3. It's given by mu3 over mu2, the square root of mu2, and that square root of mu2 again is cubed. So if you look up there, you'll see that mu3 is 993.59, or this we divide by the square root of mu2. Mu2 is 485.26, 485.26, and that again is cubed. When you work out that, you should get 0.0929. Already this is a positive figure. So this is positive skewness. So what does this mean? The marks, the distribution of marks has a long tail to the right. It has a long tail to the right. What did we say a long tail to the right mean? It means the peak is somewhere here. So just like we said in the earlier lesson, that distribution of marks is not very good, although this coefficient is actually close to 0, but it actually indicates positive skewness, a longer tail to the right. So we have seen how we use moments to investigate the skewness and the peakedness of a distribution. So our lesson for today ends there. Thank you.